China just built a six-wheeled vehicle with a two-seat aircraft hidden inside the back. It is called the Land Aircraft Carrier, and it is not just another flying car concept. XPeng says it already has more than 7,000 orders, with early deliveries expected late this year and full-scale delivery planned for 2027. So what happens when the flying car stops being a futuristic drawing and starts becoming something people can actually order? The machine behind this headline comes from XPeng's flying car unit, now branded as Arridge. XPeng is already known as a Chinese electric vehicle company, but the Land Aircraft Carrier is something different. It is a two-part system built around a simple but strange idea: a ground vehicle that carries its own aircraft. The ground vehicle looks like a large six-wheeled electric truck from the future. Arridge calls it the ground mothership, and the name fits because the vehicle does more than drive. It carries the aircraft, stores it, protects it, and serves as a mobile charging base. Inside the rear section is a separate electric aircraft, folded down so it can fit inside the vehicle until the user reaches a place where flight makes sense. That is the part that makes the product easy to understand visually. The whole car does not lift off the road, and the car does not unfold wings and become an airplane. Instead, the aircraft lives inside the vehicle, then separates when it is time to fly. The road machine handles the ground, while the air module handles the sky. The aircraft is designed for two people. Arridge describes it as an electric vertical takeoff and landing aircraft, which means it can rise straight up without a runway. The aircraft uses a six-rotor dual-duct design with foldable blades and arms, so it can shrink down enough to fit inside the carrier and then expand when it is deployed. In simple terms, it works more like a compact electric aircraft than a traditional airplane. The carrier vehicle is also built to do more than look dramatic. Arridge says it uses a 6x6 all-wheel drive layout, rear-wheel steering, and an 800-volt silicon carbide range-extended power platform. The company claims a CLTC combined range of more than 1,000 kilometers for the ground vehicle, and says the carrier can recharge the aircraft while driving or parked. Arridge also says one full aircraft charge can support up to 6 flights, though real-world use would depend on conditions and flight distance. The price is still far beyond ordinary buyers. Reports from China have put the expected price below 2 million yuan, which is roughly under $300,000, depending on exchange rates. That makes it cheaper than many private aircraft, but still expensive enough that the first buyers will likely be wealthy individuals, companies, tourism operators, and specialized users, rather than normal families. The important part is that this product has moved beyond the usual flying car fantasy. Reuters reported that XPeng had received more than 7,000 orders, mostly in China, while the company continues working to obtain approval from aviation authorities. Early deliveries are expected late in 2026, with larger-scale delivery planned for 2027. That does not mean these vehicles are about to fill the sky tomorrow. It means the idea now has a product, a price, an order book, and a company trying to turn it into a real delivery program. The stranger question is no longer whether someone can build a flying car concept, but how someone would actually use one. Picture the experience from the user's side. You start on the ground, driving the carrier like a large electric vehicle. The aircraft is folded inside the rear compartment, protected by the body of the ground vehicle instead of sitting on a trailer, waiting at an airport, or needing its own hangar. On normal roads, the carrier is the vehicle you use, and the aircraft simply comes along with you until the moment it is needed. That moment would not happen in the middle of traffic. The Land Aircraft Carrier is not meant to jump out of a jammed highway or take off from a crowded city street. The user would need a suitable open area or an approved future launch site where the aircraft can deploy safely. Once the carrier is parked, the rear opens, the air module comes out, and the rotors and arms unfold into flight position. Then the aircraft becomes its own vehicle. 2 people can get inside for a low-altitude flight, while the ground carrier stays behind. After the flight, the aircraft can return, fold down, and be stored back inside the carrier. The ground vehicle can then continue the trip on roads or recharge the aircraft for another flight later. That sounds like science fiction, but the logic is practical. A road vehicle is good at covering long distances on highways, carrying weight, dealing with rough roads, holding equipment, and reaching places where aircraft cannot land. A small aircraft is better at crossing terrain, water, hills, traffic, or remote areas where roads turn a short distance into a long drive. XPeng's system does not force one machine to do both jobs at the same time. This is why the land aircraft carrier feels different from the old flying car dream. For decades, people imagined a car that would drive down the road, spread wings, and fly away. The problem is that cars and aircraft are built around very different requirements. A road vehicle has to be heavy enough to survive crashes, stable enough for highways, comfortable enough for daily driving, and practical enough to park. An aircraft has to be light, balanced, efficient, and safe in the air. Combining those jobs into one machine creates difficult compromises. If the aircraft carries too much road hardware, it becomes heavier and harder to fly efficiently. If the road vehicle carries too much flight hardware, it becomes more complicated and less practical to drive. Arridge's design avoids some of that by making the carrier and aircraft separate, while still packaging them together as one system. That is why the first realistic use cases are probably not daily commuting. The vehicle makes more sense for adventure travel, scenic tourism, emergency access, remote locations, and places where the road is slow, but a short flight would be useful. A resort could use it for controlled sightseeing flights. A rescue team could use it to cross rough terrain. A wealthy owner could use it for outdoor trips, where the aircraft adds a new layer of mobility. The product is not trying to replace every car in the city. It is trying to create a bridge between road travel and short-distance flight, and that bridge only becomes valuable if the country around it is ready to support low-altitude aviation. That is why China's bigger plan matters. China is not treating low-altitude flight like a random toy market. It is trying to build what officials and companies call a low-altitude economy, which includes drones, cargo aircraft, inspection aircraft, rescue flights, tourism flights, electric vertical takeoff aircraft, and eventually passenger mobility services operating below traditional commercial aviation. The land aircraft carrier fits directly into that push. It is not only an unusual product from one EV company, it sits inside a larger effort to turn the airspace above roads, buildings, farms, mountains, and tourist areas into a new transportation and service layer. Reuters reported in 2024 that China's aviation regulator expected the low-altitude economy to grow into a 2 trillion yuan industry by 2030, while manufacturers were testing larger cargo drones and companies were planning air taxi services. China has several reasons to move quickly here. It already has one of the world's strongest electric vehicle supply chains, with battery factories, motor suppliers, power electronics, software teams, and large-scale vehicle manufacturing. It also has major drone companies and a domestic market where new transportation technology can be tested and scaled if regulators allow it. A flying car system needs all of those pieces at once: batteries, electric propulsion, lightweight materials, software, charging, manufacturing, and airspace management. XPeng also has a reason to chase this category. The electric car market in China is extremely competitive, and automakers are looking for ways to move beyond selling ordinary EVs. A product like the land aircraft carrier gives XPeng and Arridge a way to connect electric vehicle technology with aviation, tourism, outdoor travel, and future mobility. It is a way to say that the company is not only building cars for the roads that already exist, but also preparing for a new layer above them. China has also shown that it is willing to certify passenger-carrying electric aircraft when regulators are satisfied. EHang's EH216-S received a type certificate from the Civil Aviation Administration of China in 2023, and EHang said the certificate made it qualified for passenger-carrying commercial operations under that approved design. That does not automatically approve XPeng's aircraft, but it proves China is creating a regulatory path for some kinds of passenger eVTOLs. That is important because flying vehicles do not become real just because they can lift off the ground. They become real when a whole system forms around them. They need approved launch sites, flight rules, maintenance networks, emergency procedures, airspace coordination, charging systems, insurance, trained operators, and enough public trust that people are willing to use them. The land aircraft carrier is one product inside that larger experiment. It may start with wealthy users and controlled scenarios, but the wider idea includes tourism, rescue, rural access, emergency transport, and trips where roads are slow and airports are too far away. China is trying to create a new layer between cars and airlines. The machine is exciting, but the system around it is what determines whether it can become more than a rich person's weekend toy. And that system still has serious problems to solve. The land aircraft carrier may be real, but the world around it is not fully ready. The first problem is approval. Reuters reported that XPeng is still working to obtain approval from China's aviation authorities for its flying cars. A ground vehicle can follow road rules, but the aircraft has to satisfy aviation regulators, and that is a much higher bar. It needs testing, safety limits, operating rules, and clear guidance for when, where, and how it can fly. The second problem is launch space. Vertical takeoff removes the need for a runway, but it does not remove the need for rules. The aircraft cannot simply lift off from any parking lot, neighborhood street, or scenic field just because the owner wants to fly. Approved takeoff and landing areas would need safe clearance, crowd control, emergency access, noise rules, and clear paths into the sky. Weather is another limit that everyday drivers may not be used to thinking about. A car can often continue through wind or rain that would ground a small aircraft. Low visibility, strong gusts, storms, and heat can change what is safe in the air. A flying vehicle owner would have to think more like a pilot than a driver, even if the controls become easier over time. Maintenance is also more serious than normal car ownership. If a car breaks down, it can stop on the shoulder. If an aircraft has a problem in the air, the consequences are higher. The air module would need professional inspections, software checks, rotor maintenance, battery health monitoring, and strict service schedules. That adds cost and makes casual ownership harder. Training is another obstacle. Companies can make flight controls simpler, and automation can handle more of the work, but users still need to understand limits, emergency procedures, airspace rules, weather, and safe operation. A flying vehicle cannot be treated like a toy because mistakes do not only affect the people inside it, they can affect people on the ground. Then there is air traffic. One aircraft flying over an open area is manageable. Thousands of low-altitude aircraft moving around cities, tourist zones, farms, and emergency corridors would require communication systems, tracking, geofencing, and airspace coordination. Without that, the skies become dangerous long before the technology becomes mainstream. Price is the final obvious barrier. Even below 2 million yuan, the land aircraft carrier is not a mass-market product. It may be cheaper than traditional private aviation, but it is still expensive for a vehicle that also needs special rules, maintenance, and places to fly. These problems do not make the product fake, they make the timeline more realistic. The vehicle can be built before the airspace, infrastructure, and user habits are fully ready for it. That is why the land aircraft carrier matters, even if it does not become normal transportation right away. The first version does not have to fill the sky. It only has to prove that a modular flying car can move from imagination into real use. Flying cars may not arrive the way people expected. The old dream was simple. A car would drive down the road, open its wings, rise above traffic, and land wherever the driver wanted. That image is powerful because it looks effortless, but real flight is not effortless. It needs rules, space, safety systems, weather checks, maintenance, and public trust. The land aircraft carrier suggests a different future. Instead of one magical machine that does everything, the flying car may become a modular system. One vehicle drives on the ground, one aircraft flies, software connects them. Approved sites make launch and landing possible. Charging and maintenance keep the aircraft usable. Airspace management prevents the sky from turning chaotic. That version is less like fantasy, but it may be more believable. The first users will probably be wealthy buyers, tourism operators, emergency teams, remote area businesses, and enthusiasts who can afford the cost and operate in controlled settings. Over time, if the aircraft becomes cheaper, easier to maintain, and better supported by infrastructure, more practical versions could appear. That does not mean every family will own one, but it could mean flying vehicles become useful in specific situations where roads are slow and helicopters are too expensive. This is how many transportation categories begin. The first products are expensive, strange, and limited. Early cars were not for everyone. Early airplanes were dangerous and rare. Early electric vehicles were costly and inconvenient. A first generation does not have to solve every problem to matter. It only has to prove that the category can leave the showroom and enter the real world. That is what XPeng and Arich are trying to prove. The land aircraft carrier is not a promise that highways will disappear or that every driveway will become a launch pad. It is a sign that the flying car idea is becoming more practical by becoming less magical. The old flying car dream was a car that turns into an airplane. China's version is stranger, a car that brings its own aircraft with it.